isothermal process, adiabatic process, isochoric process, isobaric process, cyclic process, then reversible and irreversible. Process. So isothermal process we discussed yesterday in detail. Adiabatic process, it has also been discussed in detail. Now we will take up the remaining processes: isochoric process, isobaric process, cyclic and reversible and irreversible. So what is isochoric process? Isochoric process means the process in which volume of the system remains constant. You know, there are three parameters which are associated with the system, P, V and T. And I told you, thermodynamical system is said to be in process if any of these three parameters changes. Any of. All the three may change, one may change. Okay? So when any of the parameter changes, then we'll say thermodynamical system is in process. So out of these three parameters in isochoric process, volume will remain constant. Now other parameters left are pressure and temperature. Okay, so what will be the relation between P and T? You have Gibbs-Hughes law. Pressure of a given mass of a gas is directly proportional to absolute temperature if volume of the system is kept constant. So P proportional to T. You can write this P by T is equal to constant. Okay. The volume is constant. You know the work done is pressure into change in volume. Work will be said to be done only when there is a change in volume. But in this case, volume is constant, there is no change in volume, no expansion, no contraction of the gas. Therefore, here work done will be 0. And if you plot a graph between P and T, it will be straight line. If you have PV diagram for this process, as volume is constant, graph will be like this. Volume is constant. And if you take VT graph, as volume is constant, the graph will be straight line parallel to temperature axis. Slope of PV diagram dP by dV. This is the slope. Process is isochoric. And when you take the slope of PV diagram, dP by dV, dV is 0, that means this slope will be infinite. Denominator is 0, change in volume is not allowed in isochoric process. You know anything divided by 0 is meaningless, infinity, undefined. So slope will be okay. Then bulk modulus, coefficient of velocity, the bulk modulus, which is stress by strain, again here the volumetric strain will be 0 and dV is 0, that means dV by V is 0. So this denominator is 0, again the coefficient of velocity or bulk modulus of velocity will be infinite. Okay. Now if you take a graph between t and p by t, what type of graph you expect? Graph between absolute temperature of the gas versus P by T. Look at this relation. P by T is a constant. Process is isoporic, takes place at constant volume. Okay, when volume is constant, there is no change in volume. There is no change in volume. Okay, and here P by T ratio, when volume is kept constant, P by T ratio is also constant. So P by T, this is constant, means Y is constant. Okay, so the graph will be parallel to temperature axis. Clear? Now if you take fourth process, that is isobaric, isobaric process, it is that process in which pressure of the system is kept constant. Out of the three variables, P, V, T, pressure is constant. Then other variables are V and T. Now how they are related to each other? This is given by Charles' law. When pressure of a given mass of a gas is kept constant, then volume is directly proportional to absolute temperature. V is proportional to T if P is constant. Here the equation of state will be V by T constant, work done, which is P into dV. This will not be zero because pressure is constant, but change in volume is allowed. When work done is pressure into change in volume. Work done may be done by the system, may be done on the system. If it is done by the system, work done is positive. If work is done on the system, then it is negative. Okay, when you are inflating the tire of a cycle, you are doing work. Okay, cycle pump is there, cylindrical part, then piston rod, handle, and then compression and that compression expansion. When you exert pressure, you apply force, then piston will go down. There will be change in decrease in volume, and pressure will also increase. The wall of the cycle will get opened and air will rush into the tube. You are doing work on. Okay? If you are on a car driven by some driver, the work is being done by the car. But if your car gets punctured, then car will not take you to your destination. Then you will have to push the car. You are doing work on the car. This work is a negative. Okay? If you take a system in a cylinder. Let us say this is the cylinder, fitted with a piston. Then there is a piston rod. Here there is a system. Let us suppose system is an ideal gas. It has its parameter P, V and T. You supply certain amount of heat. What will happen? When you supply heat to the system, then temperature will change. Okay, there will be expansion in the gas. Then this piston will go out. Let us say A is the cross section area. Cross section area of the piston. Okay, and piston goes out through some distance dx. Piston goes out through certain distance. Because of this pressure P, there is a force. You know, pressure is force upon area. The force developed, that is pressure into area. Because of this pressure, the force will be developed when you supply heat energy. Okay, piston will be rushed out through certain distance. Work will be done. Whenever there is a displacement, work is had to be done. In thermodynamics, the work done is pressure into change in volume. Means work will be done on the system or by the system if there is a change in volume. So we want to prove this relation. Where from this relation has come. So we have taken a gas or a system contained in a cylinder fitted with a piston rod is there. Okay, this part is conducting, heat can enter into the system, then temperature will increase, there will be expansion. Whenever you add heat to the system, there may be expansion. Here expansion is allowed, only pressure is kept constant, volume may change. Here there will be expansion, increase in volume. So this piston will go out through certain distance. Okay, the work done is by the system. Work done is force into displacement. Force is pressure into area. And displacement is dx. But this cross-section area into this displacement dx, this is the change in volume. A into dx is change in volume, increase in volume, expansion. This is the increase in volume. This is cross-section area into the displacement. So work done is P into dV. When you see there is a small increase in volume, small work will be done. And if you say that there is a very large increase in volume, then you integrate initial volume to final volume, you will get total work. Okay. Yesterday I told you the work done is also equal to, if you take a system in two states, initial state corresponding to A, parameters are P1, V1, it is taken to new state B, where the parameter they get changed from P1 V1 to P2 V2. Okay. With increase in volume, there is decrease in pressure, and work done is P into dV. So you can get this from this graph also, from this PV diagram. PV diagram is also called indicator diagram. Why indicator? What it indicates? What is happening to the system? There is expansion or a contraction. If there is an increase in volume, initial volume is V1, final volume is V2.
Yes, sir.
There is an expansion indicated by this arrow. System has gone from A to B state. A to B state means corresponding to A state, the volume was V1, corresponding to B, which is the final state of the system, volume is V2. And V2 is greater than V1. When final volume is greater than initial volume, there is an expansion. If you take a small portion of this graph small portion A, B, C, D. Corresponding to D, volume is V. Corresponding to C, the volume is D plus dV. This is dV. Small increase in volume. From D to C, corresponding to point D, volume is V, and corresponding to C, volume is V plus dV. But during this small change in volume, if you see the graph, there is no much change in pressure. Pressure is almost constant. Okay, and if you take the area under this part AB of the graph, area is area of this rectangle A, B, C, D. You have taken a small portion of the graph. You have taken a small change in the volume. When there is a small change in volume, small work will be done by the system. Okay, and you have already proved work done is P into dV. Work will be done when there is a change in volume, and we have taken here a small change in volume from V to V plus dV. During this small change in volume, pressure is almost constant. Then you see the area, shaded area. So one side will be P, another side will be dV. So this shaded area is P into dV. Shaded area is rectangle in shape. One side P, another side dV. That means to change the value of the system by a small amount, you have to do a small work, that is this dV. And if you want total work done, when system is taken from A state to B state, when there is a large increase in volume from V1 to V2, okay, so this you will get area, total area under PV diagram. Means you can divide this part AB into small portion. As you have taken a small portion AB, the work done is area under AB, that is area A, B, C, D. Similarly, you take another part of the graph, okay, on this side, another part of the graph on this side, keep on adding this small work, then you will get total work done by the system, and system is taken from A state to B state when there is a large increase in volume from V1 to V2. Mathematically, just integrate from V1 to V2, and graphically take the total area under the graph between the two states A and B. इसके अंदर जितना भी एरिया है वो आप ले लो, ठीक है? Therefore, when you are dealing with isobaric process, pressure is constant. There is a change in volume, and whenever there is a change in volume, work is done. So therefore, work done in isobaric process is P into dV. If pressure is constant, change in volume is not zero. That means certain work has been done by the system. That work you can calculate by either by this expression or by plotting PV diagram, taking area under the PV diagram. That will give you total work done. Okay. Then, if you consider this isobaric process graphically, then see the graph. First graph, V into T. Here P is constant. The other parameters will be V and T, and V will be directly proportional to T. Then graph will be straight line inclined to temperature axis, passing through region. Clear? Then if you take PV diagram, as pressure is constant, graph will be parallel to volume axis.
Yes, sir.
Now if you take PT diagram, graph between pressure and temperature, as the process is isobaric in which pressure is kept constant, then again graph will be parallel to temperature axis. Number 4, if you take graph between volume and V by T,
Yes, sir.
as pressure is constant, V proportional to T means V by T constant. Therefore, this graph will be
Parallel to T. Sorry.
volume axis. You can have another graph between absolute temperature of the gas and V by T. Again, V by T, this ratio has to be constant for isobaric process. So this graph will also be
Parallel to T.
straight line parallel to temperature axis. Clear?
Yes, sir.
So we have discussed almost 4 important processes: isothermal, adiabatic, isochoric, isobaric. Then cyclic process. Cyclic process is a process in which system is brought back to the initial state. Okay? In that case, cyclic process again, thermodynamical process is that in which any of the parameters of the system, any of the parameters changes. Okay, in cyclic process what will happen? The difference is that if you plot PV diagram, okay, system is to the state A initially with pressure P1, volume V1, goes to the state B, takes the parameter P2, V2, then goes from B to C with pressure P3 but volume V2. When system goes from B to C state, there is no change in volume. This part is vertical, making 90-degree angle with the volume axis. Okay, whenever graph is parallel to either y-axis or x-axis, something is constant. It is parallel to y-axis.
Volume constant.
Okay, so any graph which is parallel to y-axis will be having constant value of x-axis. Here x-axis parameter is volume. So when system will be brought from B to C state, volume will be constant. The pressure will change from P3 to V2, but volume will remain same. Whatever volume was correspond to the state B, same volume correspond to the state C. Now again system is taken back from C to A. When system is taken from C to A, the CA part is parallel to volume axis. It means pressure is kept constant. P is constant. Okay? This is a cyclic process. System went from A to B state, then was taken from B to C state, then it is taken back from C to A state. the system has attained the original parameters, original volume, original pressure, original temperature. Okay?
सर सी में P1 नहीं होना चाहिए
Huh?
P1 सी में
C में the pressure is this.
क्योंकि सर
तो
A
सर
और
P2
B
का हमने वो क्यों लिया था?
हाँ सर
ये P2 है ना?
हाँ जी
Yes,
सर
sir.
ये P2 है. This is P2.
सर मतलब जो P1 है
सर,
और
जैसे V2 था तो हमने नीचे V2 लिया था,
हाँ.
तो वहाँ पे P1 है
So
तो वहाँ
here,
पे
here
P1.
pressure is here P1, so it will correspond to this.
ओके सर
Means P3 has a value equal to P1.
यस सर
This pressure is not equal to this. That means while going from B to C, pressure has changed. And this is the third state. I have taken P3. And in this special case, P3 is equal to P1.
यस सर
Okay?
Yes, sir.
As here, V3, if you take the parameter of C as P3, V3, then you will say, oh sir, V3 is equal to V2. This volume same.
यस सर
Then you can restrict by taking the special values of volume and pressure.
यस
So similarly here P3 is equal to P1. This is possible if this graph is parallel to volume axis. If it is not parallel, then P3 will not be equal to P1. And if this is not vertical, then V3 will not be equal to
V2.
V2. Get my point?
Yes.
Huh. So this is a cyclic process. It has completed in 3 steps. First step, the system was brought from A to B state. Okay, what is the work done? When system goes from A to B state, the work done is area under the graph. If you take this as C1, this as A1, then work done when system goes from A to B is area A, B, C1, A1, A. Area under the PV diagram. It is a PV diagram. PV diagram, for first part is AB, which is a straight line inclined, not parallel to any of the axes. So area under AB is AB, C1, A1, A. Okay, and if you look at what shape of the diagram, it is a trapezium. Trapezium is a quadrilateral where one pair of opposite sides parallel, not equal. This is parallel to this. One pair parallel, unequal, and this forms a trapezium. Trapezium is a special equilateral quadrilateral. So area in terms of this work in terms of area is this. Now you have to attach sign. If this work is positive or negative. Whenever there is an increase in volume, going from A to B, V2 is greater than V1. And there is expansion, there is an increase in volume, work done is positive. You know sign convention. There are 7 or 8 sign conventions in thermodynamics. Sign conventions. Heat added. If you add this heat added is taken positive, and heat removed taken from the system is negative. Increase in volume is taken positive, decrease in volume taken negative. Work done by the system is positive, work done on the system is negative. Then increase in internal energy is positive, decrease in internal energy is taken negative. So in any of the processes, we'll make use of these sign conventions. So here, the system is taken from A to B state. There is an increase in volume. The work done is positive. Why? Because work done is P into dV. When dV is increase in volume, it is taken positive, so work will also be positive. So this is positive work. Then system is taken from B to C state. From B to C state. What is the work done?
B to C.
Yes.
Pressure is decreased, right? Sir, negative. Negative नहीं है.
Look here, work is when there is a change in volume. When system
Volume
goes from
constant.
B to C, there is no change in volume.
Positive.
No change in volume. Change in volume 0. How much is work done? P into 0.
Infinity.
P into 0.
0.
The work done is 0. When I am talking about work done by the system or on the system, and you know the formula for the work done, and then see what happens to these parameters to decide the work. Now I have taken the system going from B to C state. The graph is totally straight line and vertical. It means there is no change in volume. When there is no change in volume is 0. No change in volume is 0. Then P into change in volume, which is 0. Product will also be 0. So no work is done when volume is kept constant. Okay, then out of these processes, find out in which case volume is kept constant. In isothermal, T is constant. In adiabatic, nothing is constant. In isochoric, volume is constant. And in isobaric, pressure is constant. If somebody asks you, when system goes from A to B state or from B to C or C to A, which process is going on? When system goes from B to C, volume is constant. Volume is constant for isochoric process. That means this part of the graph shows isochoric process. And when it is brought from C to A, pressure is constant.
Isobaric.
When pressure is constant, it is isobaric process. So this part, CA, indicates isobaric process is going on. B to C indicates isochoric. Then when it goes from A to B, A to B, प्रेशर बड़ा है. A to B में प्रेशर बड़ा है. P1 से P2 है. वॉल्यूम भी बड़ी है. V1 से P2 है. प्रेशर भी चेंज हुआ है, वॉल्यूम भी चेंज हुई है. टेम्परेचर की बात नहीं की गई. ओके, अब जब हम P और V का ग्राफ प्लॉट करेंगे तो टेम्परेचर कांस्टेंट ही रखेंगे. ग्राफ इज बिटवीन टू पैरामीटर्स, but the system has 3 parameters, P, V, T. When you plot a graph between any of the 2 parameters, third parameter is supposed to be kept constant. So it will be corresponding to isothermal process. Okay. Now system started from A state, then followed the path A, B, C, A, brought back to the initial state. Such a process is called cyclic process. And work done during the cyclic process is work done. Otherwise, in PV diagram, work done is area under the graph. Now this graph has 3 components: AB, BC, CA. And in one part BC no work is done. In AB part positive work is done. Okay, and for this portion C to A, from C to A,
Negative.
how much work is done? work is P into dV, and here there is a decrease in volume. V2 is more than V1. The system goes from A to C to A. There is a decrease in volume. Decrease in volume is taken negative. The work done will be negative. So this work will be negative. How much this is? Area under this portion of the graph. So it is equal to area C A A1 C1 C. So what is the net work done? Net work done AB plus this plus WBC plus WCA. This is area A, B, C1, A1, A. This is 0 and this is negative work. This is negative. And this is equal to area CA, A1, C1, C. Means this area minus this area. This whole area minus this area. That is area of the triangle. So this is equal to area enclosed by the cycle. Cyclic process is a process in which system is brought back to the initial state. System will attain the same values of all the three parameters after undergoing various processes. So in this graph, which out of these processes have taken place? A to B indicates isothermal process, B to C
ISO.
when volume is constant isochoric process, C to A
Isobaric.
isobaric, pressure is kept constant,
Yes, sir.
okay, and there is overall cyclic process,
A to B is also.
okay, and it is reversible also.
Yes, sir.
When system achieves the same values after undergoing various processes, we will say okay, entire processes are reversed. So it is a reversible process also. Clear?
Yes, sir.
Yes, sir.
So we have taken all thermodynamical processes and especially work done during various processes. Then work done is positive or negative done by the system or on the system, and in a cyclic process. Okay, out of these various processes, you can look at the graph and you can tell which type of process is indicated by a particular part of the graph. For example, I give you one question, that is PV diagram for three different processes. The first process is indicated by AB. Second is shown by AB1. Third by AB2. Okay, this is a PV diagram corresponding to three processes indicated by
PV.
these three graphs. One is AB, another is, means here system is taken from A to B state, then it is taken from A to B1 state, A to B2 state.
Yes, sir.
Clear?
Yes, sir.
Starting point and the finishing point. Okay. So first of all, you have to label which part of the graph is indicating which process. For example, AB. Here, this graph is parallel to volume axis.
Isobaric.
That means its pressure is constant.
Isobaric.
Okay. out of various processes, in which process pressure is kept constant?
A to B isobaric.
Yes. So this indicates isobaric process. Okay. Is there any cyclic process? No. Okay. Any part of the graph indicating reversible process?
No sir.
No. क्योंकि A to B चला गया, B to A नहीं आया.
Yes sir.
None of these three graphs shows reversible or irreversible process. Then this is
Irreversible.
reverse तो हुआ ही नहीं ना.
Irreversible.
One direction process चली है.
Yes sir.
Secondly, it is not a cyclic. Okay. Thirdly, then we are left with four processes: isothermal,
Isothermal process.
adiabatic, isochoric, isobaric. Okay, iso means something constant. And second process, not starting with iso, adia, nothing is constant. Remember, wherever you make use of iso word, iso means something is same for something same
Constant.
for the entire process.
Yes sir.
For example, isothermal process, temperature is constant, it will remain same throughout the process. Here, nothing is constant, all variable. इसमें कोई भी कांस्टेंट नहीं है. ये टेम्परेचर कांस्टेंट, here pressure constant, here volume constant. The isochoric, volume constant, isobaric, pressure constant. The first part AB
Isobaric.
shows that the system is taken from A to B state, pressure remains constant. And when pressure is constant, the process is isobaric. Now you are left with, here in adiabatic process nothing is constant, but we are taking a graph between P and V.
Temperature is
Iso-
constant. Isothermal
Iso-
process.
P and V. P and V
Iso-
means third
Temperature
parameter
constant.
temperature is kept constant. Acha, then how to differentiate adiabatic and isobaric? Isobaric तो हमने डिसाइड कर लिया.
Yes sir.
Now isobaric, isochoric, volume constant. यहाँ तो कहीं भी वॉल्यूम कांस्टेंट नहीं, फॉर ऑल द थ्री ग्राफ्स जो वॉल्यूम है वो तो चेंज हो रही है. वॉल्यूम यहाँ से यहाँ चेंज हुई है, तो आप सिर्फ वॉल्यूम शो करो. अगर यहाँ देयर इज ए प्रेशर P1 V1, तो यहाँ आप क्या देख रहे हैं, ये वॉल्यूम V1 है. यहाँ प्रेशर सेम है लेकिन वॉल्यूम चेंज हुई है. प्रेशर सेम है P1, अच्छा इट विल बी V. यहाँ यहाँ
Volume change.
लेटर से कि यहाँ तो प्रेशर भी चेंज हुआ है, वॉल्यूम भी चेंज हुई है,
Yes.
क्या नहीं?
Yes. नहीं सर, वॉल्यूम तो कांस्टेंट ही है, प्रेशर चेंज हुआ है यहाँ पे.
नहीं सर, टेम्परेचर कांस्टेंट है तो
I
चेंज हुए.
am considering these three graphs independently. ठीक है ना? एंडिंग पॉइंट इज B, तो B पे वॉल्यूम
ये तो सेम ही
सभी के लिए सेम मिलेगा,
Yes sir.
वॉल्यूम सेम मिलेगा, whatever it is, but it is different from this.
Yes sir. P2 V.
ठीक है?
P3 V. Yes sir.
Okay. Now to identify these two graphs, you have to go for the slope of the graph, slope of PV diagram. You know, slope of PV diagram is dP by dV. And this dP by dV, which is a slope, it is for adiabatic, it is greater than the slope for isothermal. You have already studied day before yesterday, I told you. Okay? Now you have to see out of this and this, in which case slope is more,
B2.
in this or in this.
B2.
B2.
Yes. Here there is a slow change, is a fast change. Slope of this is greater than slope of this. Therefore, this will indicate
Adiabatic.
adiabatic. And it will indicate isothermal. So the first part out of these three graphs, PV diagram, you have to identify which process is indicated by which part of the graph. That you have identified. My second question to this problem, in which case maximum work is done? Maximum work.
B2.
Work is area under the graph.
AB.
एरिया अंडर ए बी ये सारा है. एरिया अंडर ए बी वन,
B1.
ये एरिया है ना, कम हो गया ना.
Yes, sir.
और फॉर दिस एरिया अंडर द ग्राफ ये और कम हो गया.
AB maximum.
तो मैक्सिमम वर्क फॉर ए बी ग्राफ.
B1.
क्लियर?
Yes, sir.
And in which case there is a minimum work.
B2. B2.
This is for the part AB2. Because under AB2 part of the graph, minimum area. Under AB, maximum area. That means maximum work is done in isobaric process. Minimum work is done in
Adiabatic.
adiabatic process. Clear?
Yes, sir.
Now I give you one more question related to graph.
Yes, sir.
I will not give you the graph. You will suggest me what type of graph. Okay?
Yes, sir.
Graph will be between P and V only. Okay, what is given? Given is there is an ideal gas at pressure P1 and volume V1. First thing which is given, ideal gas at pressure P1 and volume V1. Clear? So you can show on the PV diagram ideal gas, pressure P1, volume V1. This will be indicated by a point
A.
with two coordinates.
A.
You can find out the point. Can we find? So let us say ये P1 है, ये V1 है, तो इसका P1 V1 का पॉइंट यहाँ कहीं होगा. Pressure is P1, volume is V1, gas is ideal. Second, an amount of heat Q is added to the gas till its pressure becomes P2 and volume V2. Quantity of heat is supplied to the ideal gas. When you have added heat to the system,
Volume increases.
and he has told you There is a change in pressure, change in volume. On adding heat, there will be expansion.
Yes, sir.
Okay. And temperature becomes okay. प्रेशर बड़ा है, वॉल्यूम भी बड़ी है, टेम्परेचर उसने बोला चेंज हो गया. अगर मैं टेम्परेचर को कांस्टेंट ले लेता हूँ, लेट अस सपोज
Yes, sir.
I take PV diagram, means you can suppose temperature constant. Okay.
P to the
So what will happen if volume pressure increases, volume will decrease.
Yes.
If you want to keep the temperature constant, on increasing pressure, volume will decrease. So let us suppose P2 is greater than P1, then V2 will be less than V1. So you can show this on the graph by this. Let us say if this corresponds to the point
P2.
A और ये हो गया B. Coordinates are P2, V2. System has gone from A to B state. There is a decrease in volume, increase in pressure. Okay. Then, after that, if heat is added at constant volume V2, this is V1, this is V2. In third step, he says heat is added to the system, to the ideal gas at constant volume V2. V2 तो इसलिए वॉल्यूम अचीव कर रही है ना.
Yes, sir.
अब volume will remain constant. Now you are adding heat. Then what type of graph further? इसके बाद क्या होगा? Volume is constant.
Pressure will increase.
Heat is being added. The other parameters P and T, volume is constant. The whole P and T are relative to each other. Pressure proportional to temperature. When you are adding heat at constant volume, then addition of heat will cause increase in temperature and then pressure will also increase. Volume constant. तो at constant volume V2 फिर ये आ जाएगा. Pressure will increase but volume will be constant. You will get a straight graph going vertical up parallel to pressure axis.
Yes, sir.
प्रेशर बढ़ रहा है, वॉल्यूम कांस्टेंट है, हीट ऐड की गई है तो टेम्परेचर तो बढ़ेगा ही. गेट माय पॉइंट? तो दिस इज हाउ यू कैन आइदर प्लॉट ग्राफ और यू कैन get the inferences from the plotted graph. It may be PV diagram or PT diagram भी हो सकता है. Okay?
Yes, sir.
So this was the various processes and then showing them graphically and identifying the various processes graphically. Now you have zeroth law